Hi students, here's your spiral review for spiral number 4. We're going to start off with some factoring polynomial stuff. In each of these cases, 1, 0 has been given, so we're going to have to do some long division first. For the first one, I'm going to put the 2 on the outside, that's where 0 goes, and then put my coefficients on the inside. So we've got 2 and then -3, -3, and then 2. For synthetic division, we always bring the first number down. Then we multiply. 2 times 2 is 4, and the answer goes up above the line in the next column. Then we add. -3 plus 4 is 1, and multiply again. 2 times 1 is 2. We add going down. -3 plus 2 is -1. We multiply once more. -2 times -1 is -2. And we add going down to get 0. That's going to be our remainder, which leaves us with -1 as our constant. Then we have our x term, 1x, and that's positive, and our x squared term, 2x squared. This is going to factor into a 2x and a 1x, and a +1 and a -1. Again, you can use any factoring method that you'd like. If you'd prefer to use a factoring calculator to help you with this part, that's totally fine. The last piece of this is to bring that 0 down as x minus 2. For the next one, we're doing the same exact thing, and I'm going to set up my synthetic division, put the 5 out front, 2, -19, 53, and -40. So we bring that 2 down. We multiply. 5 times 2 is 10. Add, we get -9. Multiply, we get -45. Add, we get +8. Multiply, we get +40, and then we get 0. Again, that shouldn't be a surprise. We're supposed to get factorable things out of this. That gets us an 8 minus 9x and 2x squared. This one I'm going to factor out, so we're going to go a times c is going to be 16, and we're trying to find things that multiply to 16 and also add up to -9. Okay, so things that multiply to 16, that'd be 1 times 16. Okay, that doesn't add to -9. 2 times 8, that gets us 10. 3 doesn't work. 4 times 4, that gets us 8. This is not factorable anymore. So the only thing that we have to do at this point for this problem is take this 5 and bring it down as x minus 5. At this point, the problem is done. And again, you're welcome to use a factoring calculator or anything else that you'd like for that. For number 11, we're doing the same thing. I'm going to set up my synthetic division. That 5 goes on the outside. On the inside, we got our coefficients, 2, -7, -14, and -5. Always bring the first number down and then multiply. 5 times 2 is 10. We add going down, that gets us 3. We multiply, that gets us 15, and then we add to get 1. We multiply. 5 times 1 is 5, and then we add to get 0. So we're left with 2x squared plus 3x plus 1. Okay, this one is factorable. This is going to be 2x and 1x and +1 plus 1. The last thing we need to do is to bring this 5 down as a factor to get x minus 5. For number 12, we're doing the same thing again. We're going to make our synthetic division, put the -5 out front, and then bring our coefficients down. So 5, 34, 49, and 20. I'm going to bring that 5 down. We're going to multiply to get -25. I'm going to add. That's going to give us positive 50-something. But I just subtracted instead of added. I'm going crazy. That's going to give us positive 9. There we go. I'm going to multiply. That gets us -45. That gets us to positive 4. -20 gets us to 0. That becomes 5x squared plus 9x plus 4. This is going to be factorable. That's going to get us 5x and 1x. And then that's going to get us a +4 and a +1. Last part, bring that minus 5 down as x plus 5. At this point, that has been fully factored. Looking at the second type of problem that we have here, this time we're given some information and we have to figure out what k has to be to make this work. Same thing. We set up our synthetic division. Here we've got 1 and then k and then minus 5 and then 10 for our polynomial. And we're told that when we're dividing by x minus 2, that gives us a plus 2 on the outside. The remainder is 2, so our last number has to be 2. I'm going to work backwards on this one a little bit because I can figure out some of these numbers working backwards just as easily. So here, in order for this to work, this has to be a negative 8 because 10 plus negative 8 gives me 2. Okay, then I've got to figure out what has to be here. It came from this number. 2 times that number is negative 8. That number has to be negative 4. Okay, and if we've got negative 5 plus something is negative 4, that something has to be 1. Now we have some kind of a fraction thing going on here, so I'm going to hold off on that. Now I'm going to start working forwards and see if that helps. Okay, so we've got a 1, and then 2 times 1 is 2, and then we've got k plus 2 has to go here. So here's the thing that we get from this. We know that the next step would have to be 2 times k plus 2, and that would go on top, and that should equal 1. When we go and solve this, I'm going to get 2k plus 4 is equal to 1, minus 4 to both sides. We get 2k is equal to negative 3. That gives me k is negative 3 over 2. So that should be negative 3 over 2 in this equation. At this point, we're done. We have solved for k. And that makes sense based on us having some kind of a weird fraction if we started to try to go backwards and divide again there. For the next one, I'm just going to do this one all the way forwards and see if you prefer one method or the other. It doesn't matter to me. So is a factor means our remainder has to be 0. And I'm just going to set this up again. We've got 1, negative 3, k, and negative 6. And if we're dividing by x minus 2, that means we have a 2 on the outside. So again, we can go all the way forward with this one. 1 down, multiply by 2 gives me 2. Add, we get negative 1. Multiply by 2, we get negative 2. And if I add those together, I get k minus 2. If I multiply that by 2, I get 2 times k minus 2. And now I have this situation where these two things added up have to equal 0. So negative 6 plus 2 times k minus 2 must equal 0. Okay, I'll do some distribution. Negative 6 plus 2k minus 4 is equal to 0. That'll give us 2k minus 10 is equal to 0. Add 10 to both sides. We get 2k is equal to 10, and k is equal to 5. Next up, we've got to do some graphing of rational functions. And the key thing that we have to do here is to make sure that we factor everything first. So I'm going to factor the top and the bottom. Again, you can use a factoring calculator to help you with this. That's totally fine. That's going to get us an x and x minus 1. On the bottom, I don't love that negative there, so I'm going to take a negative 4x out. And that would get us an x and a plus 1 on the bottom. Okay. Now I'm going to do my excluded values as soon as I factor. X gives us x cannot equal 0. X plus 1 gives us x cannot equal negative 1. Now I'm going to cancel stuff out. I'm going to cancel x and x out. That means that x equals 0 is going to be a whole because that's what that excluded value would have been. The remaining piece in the bottom, x plus 1, is going to be a vertical asymptote. So x plus 1 equals 0 gave us x equals negative 1. So I'm going to write this as x equals negative 1 is our vertical asymptote. And I'm going to put that on my graph right now. So that's negative 1. All right, for horizontal asymptote, We've got the same power on the top and the bottom. The way that we can shortcut that is to write this as kind of the ratio of leading coefficients. That would be y is equal to negative 1/4. So I'm going to put that on here now. Y equals negative 1/4. X-intercepts. So now we're talking about the equation. I'm going to change colors. Now that we've reduced this, we've got x minus 1 on top and negative 4 times x plus 1 on the bottom. For the x-intercepts, it's whatever makes the top equal to 0. So x minus 1 equals 0. X equals 1 would be the x-intercept. So I'm going to put that on here. For the y-intercept, that's when we plug in 0 for x. So when I do that, we get 0 minus 1 on top and negative 4 times 0 plus 1 on the bottom. That would be positive 1/4. There's 1/4. Here's 1. And that's all the information that we're looking for. Since we have access to Desmos, we can use that to help us and get the shape of the graph. It's going to look something like this. I did forget something. We've got a hole at x equals 0, so that y-intercept is not actually going to be on the graph. It's going to be a hole instead. Same thing, we're going to start by factoring. Top's already set up for us. The bottom, I can take a 4 out and get us x minus 3. So not a heck of a lot to factor or cancel here. The excluded value is going to be x minus 3 cannot be 0, therefore x cannot be 3. There's nothing to cancel out, so there will be no holes. Vertical asymptotes is just going to be whatever we have left, and that's going to be x equals 3. 2, 3. And here's my vertical asymptote. Horizontal asymptotes, we've got the same power in the top and the bottom. I'm going to do the ratio of the leading coefficients, and that gets me 1/4. So I'm going to put that one in here. Cool, I like it. X-intercepts, whatever the top would be 0, so x plus 4 is equal to 0. That gets us x equals negative 4. So I'm going to put that on here. And then we're looking for a y-intercept. I'm going to plug 0 in for x. We get 0 plus 4 on the top. And we've got 4 times 0 is 0 minus 12 on the bottom. That gets us negative 1/3. Alright, so a nice sketch of this. It's going to look something like this. And again, you have Desmos that can help you get the sketch of that graph in the right places. For the next one, we are identifying some important characteristics, and again, sketching this thing. Here we have some factorable stuff. The top is going to factor into 3x and x minus 2. The bottom is going to factor into, looks like x minus 3 and x plus 1. Nothing is going to cancel out, so we're going to have a whole bunch of stuff going on here. Excluded values, x cannot be 3 and x cannot be negative 1. Those are from my denominator. Neither of those cancel out, so those are both vertical asymptotes. So I'm going to put at, so this should be negative 1. Negative 1, we've got a vertical asymptote. And at 3, we've got a vertical asymptote. For horizontal asymptote, we've got the same power on the top and the bottom. So I'm going to do the ratio of the leading coefficients. 3 over 1 is 3. X-intercepts, I'm going to set the top equal to 0. 3x times x minus 2 is equal to 0. That tells us that x equals 0 is going to be an x-intercept. And that x equals 2 is going to be an x-intercept as well. For the y-intercept, I'm going to plug 0 in, and when I do that, I get 0 times x minus 2 on top. By that I mean 0 minus 2. And the bottom we get 0 minus 3 times 0 plus 1. That's going to be 0, and we already have that point on our graph. Nothing canceled, so we have no holes. All right, the inside of this is going to look something like this. And again, you have Desmos to help you with this, so once you have these points and asymptotes identified, please use Desmos to help you sketch the graph. Should have a piece up here and a piece up there, but those might be flipped. For the sake of speed, I'm just going to let those be even if they're wrong. All right, the last of these for the practice. Again, we're going to factor some stuff. This is going to factor into x plus 2, x minus 1 on top. And the bottom is going to be x minus 3 and x plus 2. You're welcome to use whatever factoring method or calculator that you'd like. Excluded values, x cannot be 3 and x cannot be negative 2. That comes from my denominator. We do have some stuff canceling out, so x plus 2 is going to make a whole at x equals negative 2. The remaining thing, x equals 3, is going to be a vertical asymptote. Horizontal asymptote, we got the same power again, so we're going to do the ratio of leading coefficients. That's going to be y equals 1. X-intercepts, we're going to use our reduced function and say x minus 1 equals 0, so that x equals 1 would be an x-intercept. And for the y-intercept, I'm going to plug 0 in. I could use either version of this. It doesn't really matter. So if I do 0, 0, 0, 0, and then negative 2 over negative 6, we end up getting positive 1/3 as our y-intercept. All right, we are good to graph this. Cool. Something like this on the other side. At negative 2, we're going to have a hole. And if I plug negative 2 in, we get negative 2 minus 1 over negative 2 minus 3. That would end up giving us negative 3 over negative 5, or 3/5. For the first time, we're also going to have to do some rational expressions and equations stuff for this spiral. And in looking at this, we're going to do some factoring and some reducing in all cases of these. So the first step is always going to be to factor anything that we can. All right, 6v plus 60. I can take a 6 out of that, leaving me with v plus 10. Nothing comes out of the bottom, so that's still v plus 9. Nothing comes out of the next top part, so that's v plus 9. And for the bottom part, that's going to factor into v plus 10 and v plus 9. Once we factor, we have to find some excluded values. If you're saying that this sounds a lot like exactly what we just did for graphing, that's correct. I've got v plus 9 on the bottom, so v cannot be negative 9, and I've got v plus 10 on the bottom, so v cannot be negative 10. Once we find excluded values, we're going to reduce. And in this case, we've got a v plus 9, v plus 9, and get rid of one of each of those. I've got a v plus 10, v plus 10, I can get rid of one of each of those. On the top, I'm left with just 6, and on the bottom, I'm left with just v plus 9. At this point, since we have identified our excluded values and reduced, we are done. For the next one, we got the same exact thing going on. I've got to do some factoring first. And when I do that, we end up with 8 is not changing, so that's cool. R squared minus r minus 6 is going to be r plus 2 and r minus 3. R squared minus r plus or minus 6. I just factored that incorrectly. I apologize. Nope, we're good. Sorry, in my head I was doing pluses and minuses backwards. So we end up with the same thing on the bottom, r plus 2 and r minus 3. And on top we have r minus 2. Okay, excluded values. So we did our factoring. We're going to have r cannot be negative 2 or positive 3. And now when we're getting to the reducing part, we're going to have to deal with this dividing. So we have r plus 2, r minus 3 on the bottom. When we're dividing, we're really multiplying by the reciprocal or the reciprocal. That puts an r minus 2 in the bottom and r plus 2, r minus 3 on top. Because we now have an r minus 2 in the bottom, I'm going to add 2 to my excluded values. This is a tricky thing that I'm not going to ask you to do on a spiral. So in terms of being careful about that, you don't have to worry about that so much. I'll give you a problem that doesn't actually cause that to happen. Okay, let's do some reducing. Reduce, 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 reduce. We have one of each of those, and we're left with 8 over r minus 2. We'll also have to deal with these in terms of solving, and we end up doing this exactly the same way. So we're always going to try factoring first. In the first one, this is not going to end up being helpful because nothing is factorable. And then find some excluded values. I can't write today, apparently. So this is x vals. There we go. In this case, n cannot be 0. That's the only thing that would cause any denominator to be 0. Here, instead of reducing, we're going to find some common denominators. So here I notice I've got 2n, 4n, and n. All of these already have an n, so we're okay. I'd like to make them all 4n if possible, so I'm going to multiply the first one by 2 over 2. That gets me 2 over 4n. And then we've got n minus 4 over 4n. And to get 1 over n to be the same thing, let's multiply this by 4 over 4. That gets me 4 over 4n. That leaves me with just the stuff on top because we're going to cancel the whole denominator thing out. We get 2 equals n minus 4 plus 4. Minus 4 plus 4 go away too. We're left with n is equal to 2 as our answer. That is not an excluded value, so we are good. For the next one, again, we're going to factor to start this thing out. I do have some stuff that'll factor this time into x times x plus 3 and x times x plus 3. Cool. My x values here are going to be x cannot be negative 3 and x cannot be 0 because those are the things we have in denominators. The only denominator that's different is the first one, and that's missing an x. So when I find common denominators, I'm going to multiply that by x over x, leaving me with the equation x over x times x plus 3 plus 2 over x times x plus 3 is equal to 1 over x times x plus 3. Since all three denominators are now the same, we can get rid of those. We're multiplying by that to cancel them out. And we're left with x plus 2 is equal to 1. Solving that, we get x is equal to negative 1. That's not one of my excluded values, so we are okay. For the last section, we're doing some graphing of exponential and log functions. You're given the mother function for y equals 2 to the x, and we're trying to graph 2 to the x minus 1 minus 2. You've got to show asymptotes. You've got to show a few points. So I'm going to do this with transformations. X minus 1 in parentheses means that we're going to go 1 to the right, and we're going to go down 2. The down 2 really affects our asymptote. So we're going to take a look at that asymptote first, and it's going to move down 2. So here's our new asymptote, y equals negative 2. To get 3 points, I'm going to use 1, 1 first. It's going to go right 1, down 2. I'm going to use the point, it looks like 2, 4. It's going to go right 1, down 2. And then I'll use the point 3, 8. And that's also going to go right 1, down 2. My new curve is going to look like this. Please label these. So that's going to be at 4, 6. This is going to be at 3, 2, and at 1, negative 1. Same thing. We're going to start off with our asymptote. This is being moved down 3. Asymptotes are not affected by the y times 3 that we'd have out front, just because they have a value of 0 to start off with. So it'd be 0 times 3 and then down 3. So here's my asymptote, y equals negative 3. Okay, same thing, let's start with 3 points. Let's go with 0, 1 to start out with. It's going to go left 1, okay? So that brings us here, and then the y is going to be multiplied times 3. So 1 times 3 is 3, and then down 3 would get us to 0. For the next point, let's go with 1, 2. I'm just going to hide my original point there. And at 1, 2, that's going to move 1 to the left, okay? And then 2 times 3 is 6, minus 3 is going to be 3. So that'd be 0, 3. Then we need a third point. Let's go with 2, 4. It's going to go left 1, cool. And then 4 times 3 is 12, minus 3 is going to be 9. So here we would be at 9. And that would be at 1, 9. All right, so we have 3 points. We know this is going to be an exponential curve that's going to go through those points and look something like this. We also have to be able to work backwards, and this is going to go step by step. So first we're going to use the asymptote. The asymptote is always equal to k. So in this case, we have -4, and that's going to get us our k value very quickly. Then we are going to use our y-intercept, because that's going to help us get our a value. And the reason that we're using that is that we can plug 0 in for x, which is really helpful. So let's do that now. So we've got 1 is equal to a times b to the 0 minus 4 for our k value. All right, b to the 0 is 1, so that kind of goes away. I'm going to add 4 to the other side, and we get 5 is equal to a. Now, I'm going to switch colors just so we can see what's going on. You're going to use another point. Of the points that were given, I'm probably going to use 1, 6, just because it's a nicer number. So we've got 6 is equal to 5, b to the 1 minus 4. Add 4 to the other side, we get 10 is equal to 5b. And divide by 5, we get b is equal to 2. My equation is going to be y is equal to 5 for a, 2 for b, x, and then minus 4 for the k. This problem at this point is now done. We're doing this again, and again we're going to start with our asymptote. That's going to be our k value. So in this case, k is equal to -3. Then we're going to switch and use our y-intercept, because that's where x is equal to 0. So when I plug that in, we've got 6 for the y is equal to a times b to the 0, and we said k was -3, so -3. b to the 0 is 1. If I add 3 to the other side, I get 9 is equal to a. Okay. Then we're going to use another point. So we're given 124 and -10. I kind of like 124 a little bit better because we don't have a -1 there. So when I plug that in, we are going to have 24 is equal to, we said a was 9, b to the 1, and then -3. If I add 3 to the other side, we get 27 is equal to 9b. Dividing by 9, we get 3 is equal to b. My final equation is going to be y is equal, we said a was 9, b is 3, to the x, and then -3 for k. Then we get into some exponential log conversions. This is based on the relationship between exponentials and logs, which I like writing as base to some exponent is equal to an answer or an argument. And in log form, that's log base b of that argument is equal to an exponent. Although e's only have 3 bars, not 4. Okay, so I'm going to convert this. So we've got 4, that's my base, 64, that's my argument,
and 3 is my exponent. That would be 4 to the third is 64. For the second one, we've got the base 12 to the exponent 2 is 144. Going backwards, we've got our base 1 over 19, so that's log base 1/19 of our argument 1 over 361 is equal to our exponent 2. And for the last one, log base 256 of our argument 1 over 16 is equal to the exponent of negative a half. Evaluating, we're using the exact same stuff. I'm going to set this equal to some exponent first, then convert. So we got base 7 to an exponent is equal to 49. That only works if that if that exponent is 2. For number 10, we've got 6 to some power is equal to 1 over 36. If you're not comfortable with working on this, one of the things that you could do would be to rewrite 1 over 36 as maybe 36 to the negative 1. And now we're seeing that this could be 6 to the negative 2. So negative 2 would be our answer here. 7 to some exponent is negative 343. That's never going to happen. I can multiply 7 by itself any number of times. It will never give me a negative number. So this one is not possible. And then we've got 5 to some power is equal to 1 over 125. That's going to be negative 3. So it flips, and it is the third power of 5. Then finally, we got some solving. We've got 3 different forms of solving. The first column is going to be ones that don't require a log. They're going to be in the same base. So I can write both of these as base 2. So that's going to be 2 to the third to the negative 3x, which is going to be 2 to the negative 9x, and then 2 to the fifth. So we get negative 9x is equal to 5. X is going to be negative 5/9. Going straight down from here, I can write both of these as base 6 because 6 to the 0 is the same as 1. And then we get negative b minus 3. Negative b minus 3 is equal to 0, therefore b is going to be negative 3. For the next column, I cannot make these in the same base, therefore I'm going to convert these to log form. Log base 8 of 35 is going to be b. We have gotten b by itself. We are done. For the next one, I've got to get the exponential part by itself first. Let's divide both of these by negative 1. And we get 8 to the x minus 5 is equal to positive 18. I'm going to take log base 8 of 18. That's equal to x minus 5. I'm going to add 5 to both sides. I like writing the 5 out front so I don't accidentally move it into the log. And we get 5 plus log base 8 of 18. For the last column, we got some log stuff. The first one's kind of a gimme because we have a log on both sides. That means the insides have to be the same too because you've got the exact same stuff on the outside. So if we've got n plus 9 is equal to 2n plus 1, I'm going to get common terms on the same side, and we get n is equal to 8. And for the last of these, we've got log base 4 of 7, n, and I'm going to put this in parentheses. The minus 9 is on the outside of the parentheses, so we're going to add 9 to both sides first to get the log part by itself. We get log base 4 of 7n is equal to 1. I'm going to convert, so 4 to the first power is equal to 7n. N is going to be 4/7.